Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving maximum number of moves in a grid. So the problem states that we can start at any cell in the first column of the matrix. So for this example, it would be we can start at 2, or we can start at 5, we can start at 3, or we can start at 10. And from these cells, well, there are 3 places that we can move to. We can move straight to the right, diagonally up, or diagonally to the bottom. But we can only move there if the value to these places are bigger than the current value. Otherwise, it is not considered a move. And in the end, we will return the maximum number of moves that we can perform from the input. So for this example, the output would be 3 because 2 can go to 4 and 4 can go to 9 and 9 can go to 11. So how will we be able to solve this? As you can see, we will use some dynamic programming. So we will start from the second column, and then for each value in the second column, we will check, is there a way to arrive there looking at the previous values? And if there is, then we will just add 1 to the value that it arrives from if the previous value is not a 0. Because if it is a 0, then that means there was no previous path to the previous value. So if that is the case, then we will still leave it at 0. I think it will make more sense as we go through this example. So let's go through this example. So we start at 4. Is there a path to 4? Yes, from 2. So what's that value? It's 1. So we add 1 over, it's 2. Look at 4. There's a path from 2. Previously, it's 2. 2 has a value of 1. So we add 1, it's 2. Look at 4. 4 can arrive from 3. So it's 2 because 3 is 1. 9 can also arrive from 3. And 3 had the value of 1. So we can set it to 2 as well. Now let's look at 3. There is no path to 3. So we will put it as a 0 because 0 implies that there's no path to there. We look at 9. There is a path to 9 and it comes from 4. And 4 had the value of 2. So we will set it to 3. Now we look at 2. There is no path to 2. So we will put a 0. Look at 13. There is a path to 13. So we will put a 3 over here. Now let's look at 5. Is there a path to 5? There is a path to 5 from 3, but 3 has a value of 0. And meaning there's no path to 3. So there is no path to 5. So we put a 0 over here. Is there a path to 3? No, there is no path to 3. So we will put a 0. Is there a path to 11? Yes, and it comes from 9. So we can put it to 4. Then we look at 15. Is there a path to 15? Yes. 3, 4, 13, 15. And what's the value where 13 is? The value is 3, so we set it to 4. And the result will be the maximum value in the grid minus 1. So the maximum value in the grid is 4, and we subtract that by 1, which equals to 3. So the maximum number of moves would be 3. The time complexity of this problem would be O of n times m, where n is the number of rows and m is the number of columns, because you have to look through each row and column. However, the space, we can implement it as just O of n, because even though I showed the entire grid to make it make more sense, but realistically, we actually only need 2 columns at a time. So after we have the first 2 columns, we can get rid of this column and just look at these 2 columns. And then after we finish this column, we can forget about this column and just look at these 2 columns. And that would be enough for us to derive to the solution. So now let's get to the coding part. So first, we're going to set the number of rows to rows, and the number of columns, we're going to call it cols, C-O-L-S, so length of grid of 0. And now we're going to make our 2-column DP grid, and we're going to call it DP. So 0 times 2 for I in range rows. All right, so and now we're going to set the first column of the DP grid to 1. So DP of R of 0 equal to 1 for R in range rows. And we will set the maximum number of moves to 0. And now we'll set up the double for loop. So for C in range 1 for second column to the end of the columns, and for R in range rows, because we're going to look at each row. Yeah, so we're going to check if the value is greater than the value to the left, and we need to make sure that the previous value is greater than 0. And if that is the case, then we can change the value in the DP grid. Yeah, now we can check diagonally to the left and up. So we need to check that the previous column is first within boundaries, and it is greater, the value now is greater than previously left and up diagonally. And we also need to check that the previous value is greater than 0. And if that is the case, then we can change the new value in the DP grid. So let me type that out, r minus 1, 0 plus 1. Okay, now we can check diagonally to the left and down, and we need to make sure that it is within boundaries and that it is greater than the value left and down. And we also need to make sure that the value is greater than 0. And if that is the case, then we can also change the value in the DP grid. So max of DP R1 and DP R plus 1 and 0, and the max between the two. Oh, sorry, 0 plus 1. And let me just go ahead and space it out so it can look more readable to you guys. I'll do that real quick. Yeah. And now we're going to update the number of max moves. And DP of R plus 1 minus 1. Now, every time we loop through an entire row, we need to clear the DP in the first column and set that to the second column. Right, so dpk of 0 equals to dpk of 1. And then we need to set the second column to all zeros. And then we can reiterate again in the next column. And we can return the max moves after we have gone through all rows and columns. Let's see if it works. Alright, thanks for watching. I hope you guys found this helpful. If you guys have any other questions, comments, or concerns, please leave it down in the comment section below. And I hope to see you all again soon.